A and B. And then I think it's, yeah, starting at C. I got D part 2 when it asks us to state the null in our alternative hypothesis. I understand that part.
Okay, so for D, first you get all your numbers and you put them in different cells in either SPSS or Excel, and then you're going to make a histogram, just like we normally do.
Okay, is this for C?
Yep.
Okay. Let me put all those numbers in.
Here, I'll show you mine. I'll screen share with you.
Okay.
1 sec.
Is it just in that you put them in column A?
Whatever column you want, it doesn't really matter. Okay, can you see Excel?
Yes.
So I put all the numbers over here in column C, and then I made the chart here. So this is the histogram that we have.
Okay, I just want to be able to make sure that I can do this in Excel.
Okay.
Okay, so I'm going to highlight all the numbers.
Mm-hmm.
And then I'm going to do what?
You go to your insert. Then you go over here to your charts, but you do the one with the blue because that's a statistical chart. And you click on the arrow and it will have options for a histogram or a box and whisker. So I clicked the histogram and it made my chart.
Okay, so mine looks a little different.
Okay.
Did you put your numbers in like smallest to biggest?
Did I put it in what?
When you put in your numbers in the column A, were they smallest to biggest?
No, it was just in the order that they gave them to me. Because making a histogram, it's going to arrange it for you.
That's weird because it didn't do that for me.
Ah, I see. 49.
There we go.
Okay.
That's what it looks like.
Today typing is hard because I messed up my finger, and so it's got this big old bandage thing on it. So I just didn't hit the 4, I guess. But anyway, there you go. You've got a normal distribution. And then if we look at our instructions, so we'll say that we put the graph here. Okay, so for part I, you need to see if the data is normally distributed. Because such a small sample size, unless it's normally distributed, like ours is, we won't be able to go any further with it.
So it says, what will you need to check if it's normally distributed?
Yep, it would be if it's normally distributed. Because otherwise, if it were skewed with such a small sample size of 15, we couldn't do anything with it. We couldn't like do a z-test because it has to be 30 or just a really large sample size.
Right.
Right, okay. So the null hypothesis would be
47 equals 47, and then
yeah, and then
not equal 47.
Yeah. And if it's not equal, that would make it a two-tailed test. Because we aren't looking for either greater or less than, we're looking for both. So then they give us our significance value. Is that what they called it?
I think
Level
so,
of significance. Yeah. And then we're going to compute the test statistic. So what's the formula to be used? So we want to use the z-score formula. and we'll put in all our numbers. So in, let's see, 47, and then we're going to want our new mean to see if
So
it's
what is our mean?
Let me calculate it. 2 equals 1 sec. Our average is 46.73 on and on.
Okay.
So we're going to want to take, well, I guess I should put it down since you can't see me. Okay. We want to take our supposed mean of our null hypothesis of 47.
Okay, 47 minus
Wait,
what?
that's correct, right? We wouldn't do it the other way. So
Right.
we're going to start off with our value, right? So 6.
Right. I think I'm doing it right. So 47 minus 46.73.
And then you're going to have that over your standard deviation, which we'll just use the one that they gave us, which is 5.
5.
And that needs to be divided by square root of 15.
That's 15.
Yep. So if we put that in, okay, what answer did you get?
I got 0.014.
Yep, that's the same one I got. So then you would put that z-score, well, I guess I'll just pull it up and see if I can find the probability applet in all my stuff.
Oh, the applet.
Yeah,
I wish you had a link for this applet, just kind of like
I know.
wherever.
I bookmarked it on mine so I could find it easier.
Oh, that's smart.
And then it will just take me right there. So first, z-score. So we had 0.013. And because it's two-tailed, you're going to want everything to the left and to the right. So you highlight both of those. And since the z-score is so small, it just equals 1. So that would be our p-value. The thing I'm wondering is, did we subtract the right numbers? Like, do we want our value first or the mean one? But I think because it's because we're trying to see if the null hypothesis is true, we use the null hypothesis first and then our new mean.
Yeah. That sounds familiar to me.
So then the area is 1, and that is equal to our p-value. And if the p-value is small, it means that the z-score was far away from 0 when we reject it. But if it's larger, then so we looked at our value of significance, right? And
Right.
that is
0.05.
0.05. So if it's bigger than that, you accept the null hypothesis. So we
Right.
still believe it's 47.
Okay. Sorry, I'm just trying to find the applet real quick. I'm gonna save it like you did. Gosh, this is so annoying. It wasn't in lesson 5, so it must be in lesson 6. Oh my gosh, where is this?
I just sent you the link, so it should pop up kind of if you click on the chat button that's to your left, it has like a little blue talk bubble. It'll show you the link that I sent you.
I don't see it. On my phone or on the computer?
Whichever one you're using to actually see me and do the video chat.
It's on my phone. Could you email me the link?
Sure.
Sorry, this is so annoying. Okay, so I just want to talk through it just to make sure that I understand. So once we find our z-score, we put it into the applet, and then we shade everything to the left and to the right. And then whatever gives us... Okay, so what was our thing?
So ours was a two-tailed test, and we got a p-value of 1.
Did you get like 0.98?
No, just 1.
And you put the z-score in as 0.014?
I believe so. Let me look. Yeah, I did.
Weird.
Are you getting something different?
I just get, in the area, it's 0.98. I mean, that's close enough to 1, but...
Oh, works either way.
Okay. Okay, so then if it's bigger than the 0.05, it means that the null hypothesis stands corrected, or the alternative hypothesis.
It means we don't reject the null hypothesis. So we can't prove it wrong, and so we stay with the null hypothesis of 47. Year-olds.
Okay, so we don't reject the null hypothesis.
Correct. Yeah.
Okay. So we fail to reject the null. Okay. Got it. Okay, and then state your conclusion in terms of the alternative hypothesis.
So
is
we
that-
say that we failed, that we rejected the alternative hypothesis because there wasn't evidence to support it.
Okay. We failed the alternative hypothesis. Okay. What action, if any, do you suggest the realtor to take based on your statistical conclusions?
Well, I think that they should still target the audience that's buying it. So, around the age of 47. So, they don't really need to change what they're doing because that's who they're already advertising to.
Right. So is that the population they're targeting?
The population, yeah, is the people making that second investment they're talking about.
Okay. Okay. So then if it's, say our p-value was less than the 0.05, then we would reject the null hypothesis, correct?
Yeah. Because it means that it's a very small chance that we would get those numbers if the null hypothesis was true. So we have to reject it. So that's how it works.
What is that squeaking? Is that a bird?
No, it's the door of the Benson building.
Okay, awesome. Well, thank you so much.
Yeah, no problem.
You want to start the quiz?
Sure.
I'm going to save this probability app. Okay, what? 21 questions.
Wow.
Okay. I completed individual preparation. Yes. I actively participated in this group's meeting. Yes.
Okay. So which hypothesis involves equality, or the equal sign?
The null.
Yep, that's right. The null hypothesis. I thought that was a good way to help us remember. I was glad that they told us that.
Yeah. See, when it comes to not math, like a lot of equations, I am not good at that.
See, that's what I am good at.
It's conceptual. Oh, I hate conceptual.
I love conceptual. Okay.
That's we're a good team.
Yes, we're go. Then the next one is, remember that the p-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually observed. When computing the p-value, which hypothesis do you assume to be true? That would be the null hypothesis. Right?
I'm just trying to wrap my mind around why. So remember that the p-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually observed. Yeah.
Okay. Suppose. Sorry.
No, I don't care. It's okay. I can still hear you, so that's good.
Okay. Suppose the null hypothesis is that the mean equals 10. Use this information to answer the next 3 questions. Which of the following represents the alternative hypothesis for a two-tailed test?
It'd be C, right?
Yeah.
Okay. Which of the following represents the alternative hypothesis for a left-tailed test?
It would be
A.
I like how the arrow points in the direction of the skewedness.
Yeah, I was thinking the same thing.
Which of the following represents the alternative hypothesis for a right-tailed test? That would be B.
B.
Well, it may have a lot of questions, but so far, it's pretty nice ones.
Don't jinx it,
Oh,
Emma.
okay. I don't believe in jinxing, but okay.
Oh, good. Remember that we determine the outcome of a hypothesis test by comparing the p-value to the level of significance or that symbol. Which relationship would result in failing to reject the null hypothesis?
If the numbers
It's
greater. Oh, failing
wait.
to reject. Let's see.
Failing to reject is greater.
Yeah.
I just mixed those up. So A, right?
Yeah.
Okay.
Which relationship would result in rejecting the null hypothesis? It would have to be less than.
So B. You know what I realized? These videos, if students were so smart and dumb at the same time to do so, they could watch the other students' videos and basically get the answers
To the
for
quiz?
the quiz. But that's only if they were correct answers, because you never know.
That's true, but we also assume that the students at BYUI are honest, even though a lot of them aren't. So,
yes,
you know,
I agree.
that is true. That's funny.
Okay. An insurance company is reviewing its current policy rates. When originally setting the rates, they believed that the average claim amount was $1,500. They are concerned that the true mean is actually higher than this. Which of the following would be the appropriate alternative hypothesis? Okay, don't say the answer yet. I'm going to try and make sure I understand this. So the alternative they want to see is higher. So would it be C?
Yep.
Yes.
You're getting it.
This is like exercise for my brain. Okay, so then the null hypothesis would be A. The average claim is equal to 1,500.
Sorry. In my computer
No,
before
you're
it
good.
dies.
No, you're fine.
Okay. The insurance company randomly selects 40 claims and calculates a sample mean of 1,650. The insurance company assumes the distribution of the sample mean is normal. Is this a good assumption? Let's see. We have it is a good assumption since the sample size is large. Well, yeah, that would be right because it's greater than 30.
Yeah, it's above 30, yeah.
Okay. What theorem or law justifies your answer to the previous question?
For 11, we did A, right?
11. Yep.
Okay. 13. What theorem or law justifies your answer to the previous question?
Okay, so we know that the law of large numbers says that the greater the number, the more likely it is to be normal distribution. You can assume it's normal. And then the central limit theorem says something about it being close to the actual population.
Here, I have it. Okay, so the central limit theorem, the distribution of sample means is normal when X is normally distributed or when, thanks to the central limit theorem, our sample size is large. So I think it's the central limit theorem
I'd
because the
agree.
law of large numbers states that as the sample size gets larger, the sample mean will get closer to the population mean.
Yeah, and we don't have two different means anyway. Not that it matters, but just saying. Which of the following is the test statistic as defined in this lesson? So let's see. They calculated the sample mean. So it would be the sample mean of X with the line over it.
So X bar or bar X or whatever it's called.
Yeah. I don't know what it's called. Yeah.
Yeah. Okay. And then Z is Z-score. S is nothing. Right?
Yeah,
And
and
then
N is
well,
the number
population, right?
that they sampled.
Yeah. Okay. The historical mean of sales receipts at a grocery store is $150 with standard deviation of $40. The store manager suspects that the average has decreased. She sets up a hypothesis test with a hypothesis. The null hypothesis is that it does equal $150, and the alternative hypothesis is that it is less than $150. She will use a level of significance of 0.05. She then takes a simple random sample of 36 sales receipts from her store and computes what is that called? The test statistic equals $144.
So the mean that she got of her data was 144.
Okay.
So I think
And what's the
you call it the
Z-score?
sample mean.
Oh, okay. Yeah.
What is the Z-score
Then
associated
is it going to be
with this?
150 minus 144?
Yeah. And then, well, I'm going to grab my calculator and do it too.
So then divided by 40 divided by the square root of 36. Dude, that so sounds like a bird. What'd you get?
We weren't given a standard deviation, correct?
No, we were. It's 40.
Oh.
Up at the beginning.
Wow, my calculator just did something really weird. Okay, I got 0.025. Is that what you got?
Yes.
Awesome. Okay. Now it wants us to use the probability applet to find the p-value.
So
Oh. And that is useful. What's up?
Huh?
It just looked like you were thinking about something very deeply, so I was just curious.
No, I was getting a goober out of my eye.
Okay, so she thinks that it has decreased. So we only want the left-hand side. So I get the area of 0.51. The p-value, yes.
Okay. Why am I not getting these same things? I got 0.49. It's close, but
I don't know why it would be giving a different value since it's the same program.
and it's to the left, right?
Yeah. Did you round anything before finishing your calculation?
There we go. Now I did it, and it was 0.51.
Okay.
Okay, 0.51. What inference would you make about the null hypothesis? Okay, don't say anything yet. Let me just. So the p-value is greater than the level of significance. So that means let me go up to the beginning one. The p-value is greater than that. That means we're failing to reject the null hypothesis.
Yes.
Okay. I need to write that because those questions up there where it has the p-value and then the greater or less than sign,
Yeah.
that's a good.
I wrote it down in my notebook so I can practice.
Yeah, I like that. Okay, p-value is greater than. I'm just going to do it in my Word document.
So for the answer for 18 about a conclusion, it would be we have insufficient evidence that the true population mean is less than 150. Because since this is a null hypothesis, we can't say that we have sufficient evidence to prove it.
So question 17 was B, fail to reject the null hypothesis. Then what is your conclusion? That's what you were just talking about.
C.
So that means that is less.
Because we don't have evidence for her alternative hypothesis, which means we keep the null hypothesis, but we can never say that we have sufficient evidence to prove something that's a null hypothesis. We just know that it wasn't proved wrong. So we say insufficient evidence.
Okay. But the true population, okay, I get it.
Okay.
Got it.
There are two types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis when the null hypothesis is true?
That's where this little chart comes in. Where's that chart? So which one involves rejecting the null hypothesis when the null hypothesis is true?
That's type 1.
Right. Okay. 20. A researcher decided that instead of using a level of significance of 0.05, he will use level of significance 0.01. Which of the following will be true?
Well, the probability of a type 2 error will increase.
This was a similar question on the prep.
Yeah. So whatever your alpha, whatever value you choose for that, if it's lower, it's going to be good for your type 1 errors, but bad for your type 2. So if it's really low, then it means that type 2 error will increase. If it were really high, it'd mean type 1 error would increase. And if it was like in the middle, then neither one.
Okay, I want you to say that one more time in just a second.
Okay.
So that I can write that like rule of thumb. So if the p-value is smaller than the level of significance, we're going to reject the null hypothesis.
Mm-hmm.
Okay. So levels of significance decreases, that means what?
So the level of significance is directly related to type 1 errors. So if it's really low,
Okay.
that means type 1 error is not very likely to happen. And if it's a
Okay.
high value, then it means that I lost my train of thought. The opposite of that is true.
If level of significance is high, what did you say?
So if it's low, type 2 error increases. If it's high, type 1 error increases.
It's low. If the level of significance is low, right?
Mm-hmm.
Type 1 or type 2 increases if it's low.
Yeah.
Okay. So then this is low, so that means B.
Yep, that's right.
Last question.
Okay. If your level of significance is 0.05, compute the probability of committing a type 1 error. Round to 2 decimal places.
Isn't it 5%?
Huh?
Isn't it 5%?
Yeah.
So 5.0 or
It would be
0.5?
0.05. It's the same thing.
Oh. Okay.
Because if they asked us about probability of type 2, then we would take what we have, we subtract it from 1. So we would get, it would be 95%. But because it's type 1, we just use the number that they give us.
Kevin, write that down too. This is good. This is good, Emma. Okay, so the probability of committing a type 1 error with a level of significance at 0.05 is 0.05.
Mm-hmm.
The probability of committing a type 2 error with a level at 0.05 is what now?
It would be 95. So it's whatever is going to make it add up to 1 is going to be the probability of the type 2 error.
Okay. Awesome.
Okay, are you ready to submit or you want to look over stuff?
I'm ready.
All right.
Hooey. We missed 3. That's still good though.
Yeah. Okay, let's see. Which 3 did we miss?
Okay, it was the z-score question. And then question 14. Defined in this lesson.
Oh, No. Wouldn't the test statistic that they defined be alpha?
But that's not an option, is it?
Yeah.
Test statistic. Here, 1 sec. Z.
What's Z? The Z-score?
Yeah. So that's what it would be.
We've already talked about that before. Okay.
Yeah, it's weird. I think in this lesson, Z represents the test statistic, but in the lesson before, it represents the Z score. I don't know.
Okay. I guess that makes sense.
And then,
I guess about 15 and 16 is we took the wrong values. We switched the ones we were supposed to subtract from each other. I think if we flip those around, then we'll have the right numbers.
do you think we got the parentheses right and stuff in the calculation? So then it would be
So instead of subtracting 144 from 150, we'd subtract 150 from 144. I think.
right. So then we'd get a negative number.
Well, that still works for a z-score.
Right. Okay, that makes sense.
I think we just need to change that, and then everything will be correct.
Yeah. Okay, so 144 minus 150 is negative 6. Divided by 40 equals that. Divided by the square root of 36. So it's just negative 0.025.
Yeah.
But then why would number 16 be wrong?
So what did you get for the z-score for 15?
The same thing, but just negative 0.025, not positive.
Huh. I don't know.
It should still be the same.
Well, maybe we should just go to the lesson and
See if we got something.
Yeah, I'm looking at the book right now. Values. So we only shade both sides of the tails when it's a two-sided hypothesis, correct?
What did you say?
We only shade two tails when it's a two-sided hypothesis, correct?
Yeah.
Okay, so what this is just it's to the left, which should be the same.
Mm-hmm.
Do you think it's because we didn't put a 0 after?
Possibly. I was wondering the same thing. That seems like it's silly.
Yeah.
I just want to make sure we're doing it right. I'm trying to find it in the lesson. So you take your number, you subtract the accepted value. So when we did the z-score, we flipped it around. So, but we already did it again. It was the same except negative, right?
Right.
So we just have to remember that from now on. And then it should be the same. So I guess we just need to add a 0.
Oh, that's weird.
Yeah.
Okay. This one more time. Oof.
So do you want to take it again?
I'm going to.
Same.
Yeah.
Do you want to take it together, or are you okay?
I think we're good.
Okay.
Yeah.
Well,
Thanks for all your help.
yeah, no problem. I'm glad I get to be a help sometimes too.
Okay. Oh, I see that Elder Oaks is coming next Tuesday
Mm-hmm.
for devotional. Are you planning on going to that? Do you want to try and do our meeting a little earlier?
What do you want to do? I don't care because I'm not really going.
Oh, okay. I'm not even in Rexburg, so I just didn't know if you wanted to go early to get a good seat or something.
Oh, no, I don't usually go. If I want to watch it, I watch it online later. Works better for my schedule.
Yeah.
So, yeah, if we just
Awesome.
do it at
Okay,
the
then
same
I'll see
time,
you.
that'd be fine with me.
Okay. Cool. See you at 1 next Tuesday.
All right. Thanks, Hannah.
Bye.
Bye.